Welcome to Industrial Automation course, ROBT308, Lecture 1, Introduction to Industrial Automation. Today's topic, syllabus, an explanatory example of an automated food production line. My name is Mohammad Mosaddeghzad. I am Assistant Professor of Robotics and Mechatronics at Nazarbayev University. My office location is room 7E 319. Office hours of this course will be at Tuesdays and Fridays from 11 to 12. Online office address, you could join this Google Meet address anytime during office hours. You could ask your question, raise your concern, and discuss the details of the course. Join the room and leave the room anytime you wish during office hours. My email address is my first name dot last name at nu.edu.kz. Syllabus of the course are as follow. Introduction to Industrial Automation, Factory Automation, which is the topic of this slide. Architecture of Industrial Automation Systems, Programmable Logic Controllers and Overview, PLC Hardware Components, Basics of PLC Programming, Developing Fundamental PLC Wiring Diagrams and Ladder Logic Programs, Programming Timers, Programming Counters, Data Manipulation and Mass Instructions, Industrial Sensors and Actuators, Function Block Programming, Structural Text Programming, and advanced topics in industrial automation. References of this course are as follow. The main reference will be Programmable Logic Controllers, written by Frank D. Petruzella, by John Wiley and Sons, 4th edition 2010. Automating with Schematic S7 1200. It's the next reference of this course. It's a very good reference specifically for TIA portal and step 7 programming, and you could use occasionally other references and refer to specific topic for further detail on the coming references. Course grading. You could see a score breakdown of this course. Quizzes, I will have almost 5 quizzes and I will drop the lowest one. The weight of the quizzes will be 15%, homeworks, almost 7 homework, and I will drop the lowest one. The weight will be 10%. Attendance will be 5%. Since we are in online classes, distance learning, we don't have conventional attendance, but I expect active participation, submitting homeworks and projects on time, plus coming regularly to office hours and asking questions and getting yourself involved with the material of the course. Midterm exam, which most likely will be a written exam, has 25%. Course project 20%, and final exam 25%. The final exam could be either in a format of a written exam, or could be a second course project. Please do not wait until the midterm to start studying, because it will be too late. If you do not understand something, come to office hours and request help, please. Okay, so we want to go to the main topic of this lecture, which is basically a typical food manufacturing line, and we want to understand what are the main processes and sections. In a food manufacturing line, many processes and control components are used. In each process according to their functions. So you could see floor map, a 3D floor map of a manufacturing line here. So the main processes, as you could see, these bullet points are bottling and capper process, shrink labeling process, time stamping process, packaging process, and casing process. Okay, so you could see all of these processes here. And the first one, bottling and capper process, is highlighted in yellow. And the other processes also, you could identify them here. In bottling and capper process, we have these elements. Vision system, which measures the figure or dimension of the project compared with given target and pass the signal to the control devices. Safety system or emergency buttons protect operators in factory to minimize the chance of hazards. Proximity sensors pass a signal to the control device when the sensor detects an object in near. So far, vision systems, safety systems, and proximity sensors, all of them are input to the system. Photoelectric sensors, they pass a signal to the control device when an object passes through a beam of light. And servo systems or motors move, rotate, or process the product with high speed and accuracy. So motors are output. PLC or programmable logic controllers operate the output devices according to the signal from the input devices and given user program. So the logic is written by the user. It processes the input, and based on the logic, will operate the outputs. And we have programmable terminals or HMI or human-machine interfaces, which they provide the interface between facility operators and the control devices. Okay, so HMI or HMIs could be both inputs and output to the system. Shrink and leading process is the next process, which you could see is highlighted in yellow. In this process, basically, the bottles, so bottles basically were filled and capped in the first process. In this process, we have this basically we have this roll of labels, and that will be shrink around the bottles. As you could see, we have the bottles here. Okay, let me just turn on the pointer. So you could see here we have filled bottles, but they don't have any label and packaging. But here you see that a roll of label is shrink around the bottle. So what elements do we have here? We have smart sensors. They measure the figure or dimension of the object, compare with given target, and pass the signal to the control devices. We have safety systems. We have photoelectronic sensors, servo systems, temperature controllers, which they measure the temperature of object, compare with given target, and operate the output devices. The next element is thermocouples. They are a special sensor for measuring temperature. And finally, PLC or programmable logic controllers. So you could see that each process usually have a PLC. The next one is timestamping process. So the buttons coming out of the string labeling process, and the proper information like time and date will be stamped on buttons. So you see it's highlighted in yellow again, that process. So we have again some elements: vision system, safety system, photoelectric sensors, programmable terminals, and auto ID systems. Auto ID systems or barcode readers record the identification information to the product directly to realize a high level of traceability. So we want to be able to trace bottles and identify different type of bottles. The next process is packaging process. So on this stage, we put bottles inside the boxes and we pass the box to the next process. In this process, we have vision systems, safety systems, servo systems, PLCs or PLC, and we have counters. And finally, casing process. In this process, boxes coming, and we want to close the labs and stamp or label them with proper information. We have safety system, servo systems, temperature controllers, thermocouples, counters, auto ID systems, and PLC.